In the first part of this lesson, we'll focus on justifying statements. We will need our pink sheet properties for today's notes and assignment. The statements we will justify follow the format if and then, where the words after if form the hypothesis and the words after then are our conclusion. To justify these statements, we begin by assuming the hypothesis is true. This means we accept the condition stated after if. For example, let's consider the statement, if the sun is out, then David will drink water. Here, the hypothesis is the sun is out. We start by assuming this is true. Now, how do we justify the conclusion, David will drink water? Let's reason through it. David sweats due to the hot temperature from the sun. This sweating is evidence that leads us to conclude that David will drink water to stay hydrated. This way, our reasoning connects the assumed condition, the sun is out, to the conclusion, David will drink water. Understanding how to justify these statements is crucial for logical thinking and problem solving. Let's explore more examples together to solidify our understanding. We will discuss algebra properties and proofs, and we're going to need our pink sheets for this handout. Justify the following with a property, postulate, or definition. So majority of these problems are in the form if and then. They are conditionals. Establish the hypothesis and the conclusion. We can see that 6x equals 18 is the hypothesis, and x equals 3 is the conclusion. Now remember, assume the hypothesis is true. Then provide a property, postulate, or definition that will lead us to the conclusion. If 6x equals 18 is the hypothesis, which you will assume true, then what reason will lead us to the conclusion x equals 3? So if 6x equals 18, then x equals 3. This is our standard algebra problem, so I'm going to go and refer to my pink sheet and find something that will relate to that. The division property of equality, which states that if A equals B and C is not 0, then A divided by C is equal to B divided by C. So you know I need to divide both sides by 6 here. And if I divide both sides by 6, x equals 3. This right here, me dividing both sides by 6, is me using the division property of equality, or POE for short. This is the answer because, again, we need to justify this statement with a reason. Number 2, if measure angle A plus measure angle B plus measure angle C is 180 and measure angle C is 50, then the measure of angle A plus the measure angle B plus 50 equals 180. Remember what I said about the hypothesis. You will assume that the hypothesis is true. Then you're going to provide a reason that will lead us to the conclusion. We can see that the measure angle C has a number. Here's measure angle C, and the measure angle C is 50. So how am I going from the hypothesis to the conclusion? Note that the measure angle A hasn't been changed, the measure angle B hasn't been changed, but the measure angle C did change because we know that the measure angle C is 50. That's because the measure angle C is being replaced by 50, the key word here being replace. So if we go back to our pink sheets, here's substitution, which is a synonym for replacing. If A equals B and x plus A equals y, then x plus B equals y. That means our reasoning for number 2 would be substitution. That's the answer for number 2. Number 3, measure angle A plus measure angle B plus 50 equals 180. Then measure angle A plus measure angle B is 130. So if I'm comparing the hypothesis to the conclusion, I can see that the measure angle A plus the measure angle B did not change. However, the 50 disappeared. So it seems like I'm going to use the subtraction property of equality here, because I'm going to subtract both sides by 50. And what do I get? Well, we know that the 50 minus 50 cancel. And then we're left with this 180 minus 50, which is 130. This process over here is called the subtraction property of equality. And yes, you can write POE instead of writing property of equality all out. Number 4, if segment RS is congruent to segment ST, then S is the midpoint of segment RT. So segment RS is congruent to segment ST. That's our hypothesis, which we will assume true. What I like to do here is draw a picture. This part is congruent to that part. So I'm going to draw a segment and show that segment RS is congruent to segment ST. So here's RS and here's ST. I need to use my tick mark, so one tick mark here and one tick mark over there, to show that segment RS is congruent to segment ST. So why are these two parts here congruent to each other? Well, let's take a look at our pink sheets. Since we are dealing with segments here, look at the pink sheet dealing with segment, which is the first page. I'm looking at the definition of midpoint. If M is the midpoint of segment AB, then segment AM is congruent to segment MB. But the format for number 4 is if segment RS is congruent to segment ST, which is showing that part is congruent to part, then S is the midpoint of segment RT. So with midpoint, it's a definition, it's a biconditional, it can go both ways. So instead of going from here to there, we should be looking at this perspective. We should be looking from here to there. So if segment AM is congruent to segment MB, why is this M the midpoint of segment AB? Well, that's because definition of midpoint. So if we look over here, if segment RS is congruent to segment ST, why is S the midpoint of segment RT? Well, again, that's because definition of midpoint. These two segments are congruent to each other because by the definition of midpoint. Number 5, if B lies in the interior of angle AOC, then measure angle AOB plus the measure angle BOC equals the measure angle AOC. So let's draw angle AOC, which is part of our hypothesis. And we know that B lies in the interior of angle AOC, so we're going to put B over here. Then I'm going to connect the two dots and form a ray. So what I want you to do is, since we have the hypothesis drawn out, do not look at the conclusion. Just look at the picture and tell me what you see. Well, we have angle AOB plus angle BOC, which will give us angle AOC. So these two angles create that whole angle. In other words, part plus part equals whole. So what do we say here? Again, we're dealing with angles. So if I'm looking at this particular pink sheet here, find the one that's appropriate. Which reason allows us to go from here to here? Well, that will be the angle addition postulate. So if B lies in the interior of angle AOC, then by the angle addition postulate, measure angle AOB plus measure angle BOC equals measure angle AOC. And that's what I mean by going from here to there. Just like number 4, if segment RS is congruent to segment ST, then by the definition of midpoint, S is the midpoint of segment RT. If measure angle A plus measure angle B plus 50 equals 180, then by the subtraction property of equality, measure angle A plus measure angle B equals 130. Number 6. If ray SW bisects angle VST, then angle VSW is congruent to angle WST. So draw your hypothesis. We have angle VST, and we know that ray SW, which I need to draw a W over here, bisects this whole angle. So what happens if ray SW is the angle bisector of angle VST? Well, ray SW is going to split this whole angle into 2 congruent parts. So that means you're going to draw an arc here and an arc there to show that these 2 angles are congruent. So angle VSW is congruent to angle WST. So let's take a look at our pink sheets. We're dealing with angles, and we see the keyword bisect. If ray OC bisects angle AOB, then angle AOC is congruent to angle COB by the definition of angle bisector. So if ray SW bisects angle VST, then by the definition of angle bisector, we can say that angle VSW is congruent to angle WST. Again, by the definition of angle bisector. Number 7, if M is between A and B, I'm going to draw that. So here's A, and this is B, and M is between A and B. Well, what's the result here? We have a part plus another part, which is going to give us the whole thing. So part plus part equals whole. And this reminds you of the segment addition postulate. So once again, if M is between A and B, then by the segment addition postulate, we can see that this part plus this part gives you the whole thing, or in other words, AM plus MB equals the whole thing, which is AB. That's your answer. Now we are going to get into the territory of algebraic proofs. One method of proving statements and conjectures is called a 2-column proof. A 2-column proof contains statements and reasons organized in 2 columns. So here are your statements, here are your reasons. They are organized into 2 columns. So let's prove this statement over here. If -5, the quantity x plus 4 plus 5 is 90, then x is equal to -21. Now remember what I said about the hypothesis and the conclusion. You will assume that the hypothesis is true, and then you're going to provide reasonings that'll lead you to the conclusion, x is equal to -21. Let's look at the first statement. -5, the quantity x plus 4 plus 5 equals 90. Well, y'all, that matches with the hypothesis of our given statement. So the first reason is always given. And this is very important to know. The first reason for the first statement will always be given. If I'm jumping to the next problem, well, the first reason will be given. The first reason over here will also be given. We say that the first reason is always given because the statement was already provided to you from the start. Now we're going to move from the given statement to the second statement. What is the second reasoning? Well, if we look at the first statement over here, I have a number in front of the parentheses. That just tells me that I need to distribute the 5 to each term. Negative 5 times x is negative 5x, and negative 5 times positive 4 is negative 20. So going from the first to the second statement, my second reasoning would be the distributive property. Now looking at the second statement, I can combine the negative 20 plus 5 together. Negative 20 plus 5 is going to give me negative 15. So looking from the second statement to the third statement, all I did was combine like terms. So you can see that we're just solving for x here. Negative 5x minus 15 equals 90. That's my third statement. Well, I need to get negative 5x by itself. So what do I need to do? Well, I need to add both sides by 15 here. And me adding both sides by 15 is called the addition property of equality. So negative 15 plus 15 will cancel, and I have 90 plus 15, which is 105. Again, that's the addition property of equality. So then I need to go from 4 to 5. In order for me to get x by itself, I got to divide both sides by negative 5. So negative 5x divided by negative 5 will give me x, and 105 divided by negative 5 will give me negative 21. So the process here, me dividing both sides by negative 5, is what we call the division property of equality. So this is the hypothesis, and this is the conclusion. Your goal was to provide these reasonings that'll lead you from the hypothesis to the conclusion. Number 9, given that C is equal to 5 over 9 times the quantity f minus 32, prove that f is equal to 9 over 5 times c plus 32. The given is your hypothesis, and the prove is your conclusion. We already said that number 1, the first statement is given. So how do I go from the first statement to the second statement? I see that there's a number in front of the parentheses, which tells me I should use the distributive property. However, if I use the distributive property, well, 5 over 9 times f would be 5 over 9f, right? Well, if I look at the second statement, I don't see a 5 over 9f. In fact, this fraction went to the other side of the equation, but just flipped. So that means I need to do something different. If I can't use the distributive property here, then I need to recall some other algebra property. I'm going to make up an example. 2 over 3 times x equals 6. Well, like always, I need to solve for x. So I need to get x by itself, and I need to get rid of this 2/3. How do I do that? Well, I know that 2 over 3 is the same thing as division. What's the opposite of division? Well, that would be multiplication. So I need to multiply both sides by the inverse. So since this is 2 over 3, I'm going to multiply this side by 3 over 2, and I'm going to multiply the other side by 3 over 2. The 3's will cancel, the 2's will cancel, and I'm left with x on the left-hand side of the equation, which is equal to 6 times 3, which is 18, and 18 divided by 2 is 9. So when I multiply both sides by 3 over 2 here, I was using the multiplication property of equality. So if we look at the first statement, I need to multiply both sides by 9 over 5. I have 9 over 5 times c, which is 9 over 5c. And over here on the right side of the equation, the 5's cancel and the 9's cancel, so I'm left with f minus 32. I'm using the multiplication property of equality. So from statement 2 to 3, I gotta add both sides by 32 here. So me adding both sides by 32 is me using the addition property of equality. So going from the third statement to the fourth statement, what do I need to do? Well, I already solved for f, but am I done? Not necessarily, because if we look at the conclusion, f equals 9 over 5c plus 32. We can see that the f is on the right side, but this f is on the left-hand side of the equal sign. So what I need you to do is look back at your pink sheet and tell me, how do I go from 3 to 4? And I'll give you a hint. If A is equal to B, then B is equal to A. And if you guess the symmetric property, that is correct. So from 3 to 4, I'm using the symmetric property. Alright, so let's turn the page over. Geometric proofs. These proofs also use variables and numbers so they can be proven using the same properties. You can use definitions, postulates, and theorems to help you prove a statement or conjecture. A theorem is just a statement or conjecture that has been proven. Here's your statement. This is the given, which is the hypothesis. And this is the conclusion, which is what we're trying to prove here. But what about the diagram to the right? Well, this is considered our given, which is part of the hypothesis. Let's take a look at number 1. It says segment CD is congruent to segment EF, which is, of course, our given. And then it says the measure of CD is equal to 3y minus 9. So this came from this. And then lastly, the measure of EF equals 15, which came from here. So the reason for this statement is given because all of these things here came from everything over here. So let's take a look at the first statement one more time. Segment CD is congruent to segment EF. What language is this currently in? Well, I see two shapes and a congruent symbol. Segment CD is congruent to segment EF. Going back to my pink sheet, we can see that two shapes over here are congruent, and we use a congruent symbol. All of these things here are in the language of geometry. So that means this is in the language of geometry. But going from the first statement to the second statement, I'm going from the language of geometry to the language of what? Well, we have the measure of CD is equal to the measure of EF. The equal sign gives it away. So going back to my pink sheets, we have the measure of DE is equal to the measure of FG. It seems like I'm going from the language of geometry to the language of algebra. If segment DE is congruent to segment FG, then by definition of congruence, the measure of DE equals the measure of FG. So segment CD is congruent to segment EF, then by the definition of congruence, then the measure of CD is equal to the measure of EF. Again, this is in the language of geometry, and this is in the language of algebra. Now recall that CD is equal to 3y minus 9 and EF is equal to 15. If we look at statements 2 and 3, CD got replaced with 3y minus 9 and EF got replaced with 15. And that means we're using the substitution property. Just a small note, we can say that CD is 3y minus 9 and EF is 15. That's because we can assume that the hypothesis is true. So statement 3 is essentially algebra from here on out. So I need to add both sides by 9, and that is the addition property of equality. So I have 3y equals 24. I got to divide both sides by 3. And me dividing both sides by 3 is what we call the division property of equality. So what were you trying to prove again? Y equals 8, which is what we have over here. See you later.